So starting with the Unit 6 discussion, and that is from Jan 2022. So the first question, the student investigate the relation between the length of a column of air and its temperature using the apparatus shown. So this is the apparatus which is shown. The diagram is not to scale. There's an open end and a drop of concentrated sulfuric acid is there, and there is an air sample. And one side it is closed. A sample of air is trapped inside the tube between the closed end and the drop of a concentrated sulfuric acid suggests why one end of a tube is left open. So what is the reason why one end is left open? So because what we want to do, we want to make sure that the pressure on this does not change, because we are investigating that what is the relation between the length of air column and temperature. So if you are investigating, or you can also say volume and temperature, if you are relating volume with temperature, so pressure should be kept constant. So how we keep the pressure constant? By keeping one side as open, as a pressure of atmosphere will be constant. So when we are investigating the relation between pressure and volume, or pressure and length, temperature and length, then the pressure should be constant. So that's why it is open, so to keep the pressure constant, or so that the pressure does not change. Students suggest that placing an apparatus in a beaker of a boiling water and allowing the water to cool down, the boiling water is a hazard. Explain one other reason why this method can be hazardous. What might be a reason that if we place this apparatus in a boiling water and then we allow it to cool, so as a result, what will happen? Because when we place this apparatus in a boiling water, as a result, the air in the column will expand rapidly. Like if surrounding this apparatus is there in a boiling water. So as a result, when this apparatus in a boiling water, this air which is inside will expand. And when this air will expand, this sulfuric acid, like this sulfuric acid or drops of sulfuric acid might come out. That is why that is a hazard, like this process is hazardous according to use of a sulfuric acid. So what might be a reason for that? That the boiling water, air will expand, and sulfuric acid, the concentrated sulfuric acid may come out. Then the next part, the capillary tube was attached to a 30 centimeter ruler. With a capillary tube, there's a 30 centimeter scale is there, placed in a beaker, and the water was heated gradually and theta was measured using a thermometer. State two techniques that should be used to ensure that the theta, the temperature measurement of a theta is accurate as possible. So a capillary tube was attached to 30 centimeter, and we change the like we place a thermometer here to measure temperature. So there is a ruler attached to this, the scale, and there's also a thermometer is placed. So how we can make sure that we record the accurate temperature? So first thing, because when we are heating a water, when we are supplying heat energy, then what might happen, the temperature, like the heat may not be uniformly distributed, as this apparatus is placed in a not boiling water, like it is placed in a water, and we supply the heat energy to the water. So when we supply heat energy to the water, how we can make sure, how we can ensure that this temperature reading is accurate as possible? As liquid, the heat energy transfer by convection. So we supply the heat, like we stir with the thermometer to ensure that there's a uniform transfer of heat energy, or throughout the liquid there's an equal distribution of heat energy, and place the thermometer closer to the apparatus. So how we can ensure that we are recording the temperature accurately as possible? That was a question. First thing, whenever a thermometer is used and you are measuring a temperature of a liquid, first thing you should stir with thermometer. To make sure temperature readings are accurate. And the second thing, what we should do, place the thermometer closer to the capillary. Then in the second part, student record the following measurements, the theta and the length. And student predicted the graph for length and theta should be a straight line, as you can see. Discuss whether the student measurement would lead to an accurate value of theta at about absolute zero. So, because what happened when we increase the temperature, the volume increases or the gas will expand. If temperature decrease, the volume will decrease, and eventually there will be a volume like volume zero at temperature at which the volume is zero. That is called the absolute temperature, or also known as the 0 Kelvin. So the question is, discuss whether the student measurement would lead to an accurate value. First thing, you can see how many times student did, only 3 times. Like student changes the temperature or measure the temperature 3 times, and then he measure the length of the air in the column. That is, so only few readings are there. How we can comment on this? Like there are few readings. If there are few readings, it won't be accurate, not too much accurate results. As if it is not accurate, the value of a theta, the absolute temperature won't be correct, will be incorrect. Because like students should have more readings, more values for temperature and the length to draw a line of a best fit to get the value for temperature in Kelvin, or the temperature at which the length of a air column is zero. So there are few readings. As a result, few readings are there and a small range of a temperature is used. So there will be high uncertainty in the measurement of a student, and then this won't be a best fit straight line as there are few readings. So increasing a number of reading will have more readings, means more accurate result. As a result, as a more accurate result, we'll get an accurate value for temperature in Kelvin, for absolute Kelvin. Is it clear? That discuss whether the student measurement would lead to an accurate value of theta at absolute zero. So we will say no, that is 1 mark. Why? Because there are few readings. So few readings, greater inaccuracy, students should have more or greater range of temperature should be used to measure the reading. In question 2, a student investigate the Lenz law. According to Lenz law, the change in magnetic field induce EMF, and induce EMF always try to oppose the change in magnetic field. So the student drop a magnet into a copper tube and measure the time for a magnet to reach the bottom of the tube. The student had a large number of copper tubes of different length x. He predicted that the magnet would fall with a constant acceleration a inside a copper tube. Devise a plan using a graphical method to test this prediction. This is the whole experiment is there. This is there in magnetism topic, like planning experiment. So we have to devise an experiment, and using a graphical method means we have to plot a graph, like we have to, which value will plot a graph, that also we have to mention. So first, as the student investigate, the student has a large number of copper tubes of different lengths, and he predicted that the magnet will fall at a constant acceleration inside the tube. Like acceleration of a magnet which is falling through will be constant. That is student want to. So first, what we can do, we can measure the length of the tube. you should mention the apparatus using a meter rule or a meter scale. Then avoid a parallax error, because when you are measuring a length, you should avoid the parallax error. Then what we will do, because we want to find a relation that acceleration of this is constant. So if a magnet is dropped from a certain height, say this was a magnet, so what is the initial speed of a magnet? The initial speed of a magnet is 0. The distance covered by the magnet, that is equals to length of the tube. So you can say L, or you can also say X, the length of a tube. They mention X, that's why we are saying X. And the moment we drop the magnet, we'll start the timer. So that is like the moment we drop, that is time 0. And the moment we'll see the magnet was coming out from the bottom, that is the second time. And we have the equation of motion. We have the equation of motion, S is equals to ut plus half at square. So if u is 0, the initial velocity is 0. So S is equals to half at square. So on, if we will plot a graph on y-axis, like we'll compare with the equation of straight line, y is equals to mx. So on y-axis, we'll plot the length of the tube, the x. You can say length of a tube or x on y-axis. And on x-axis, it will be time square. So what will be our gradient of this graph? The gradient of the graph is a by 2, or gradient times 2 should give us a. So gradient multiplied, but this is acceleration is not due to gravity, as there is a we have to show that it is constant, like acceleration is constant. So means the gradient times 2 will give us the acceleration. So what we will do, we measure the length of a tube using a meter rule, and we avoid a parallax error. Then we will release the magnet from the top. And we will start the timer. And using a we can use a stopwatch, mention the apparatus, record the time taken by a magnet to fall, or move through the then we will repeat. Whenever you're repeating experiment, minimum 5 times is repetition is okay. So repeat with 5 different lengths. Then we will plot a graph between the length on, and you have to mention that which axis, on y-axis, and the time square on x-axis. And acceleration will be equal to 2 multiplied by gradient. And because if we want to show it should, as a student want to show that it should be a constant acceleration. So if it's a constant acceleration, so graph between x on y-axis, like the length on y-axis, and the time square on x-axis should be straight line. If it is a straight line, that gives an idea that acceleration will be constant. Otherwise, the acceleration will change. Is it clear, this experiment? This is same as like finding the acceleration due to gravity, the experiment you did in AS, when an object is falling through a cylindrical tube and we are finding the acceleration due to gravity. It's a same one. Is this clear?